Hello, everybody. Today I want to talk about the GRE tunnel, generic route encapsulation. There is a way that you can imagine that we have a building, this is a central building, and we have a branch is in another city, and we have just the connection of the internet. So the communication between them is just internet, and we want to set and use this internet, make a tunnel uh, between these two locations. It is point to point. So today I am talking about the tunnels that it is point to point. Later we will talk about the multi-point and the DMVPNs, and it is useful way to connect different from one central to other buildings or other branches. Okay, let's take a look. First, I show you the interface of router 1 here. Uh, I got a show IP interface brief. You can see here the interface of F00 is 6001. For now, leave it 10001. Later, we will add one connection like a service provider, MPLS or something, to get more details about it. For now, we can ignore the interface of 10. We have a loopback here. I write it here. This is a loopback here. We will set the range of the IP tunnel in this range. Uh, Here also we will go and check the IP interface. Here the interface set 8001. Again, ignore 10002. Later we will use it. And the loopback that we have here. So now I want to go and configure the tunnel between these two routers. So I am going in a conft interface tunnel. You can choose one, two, three, up to you that which numbers you want to create. The first things is that uh, before I start, uh, I need to show you we need to set tunnel source. So where is our source? From this side in router 1, here is the source that the encapsulation data will go throughout. So I choose it F00. Then I need to choose the destination also. Where is our destination? From here comes to this side. So this interface is the interface that comes inside it. The right, I will choose the IP of this interface. It is 8001. So I put it 8001. Okay, I add it. Then you will see it shows the tunnel is up. But this is some kind of tricky. It's not in fact up because we didn't set any tunnel in router 3, and this is something that may confuse you. So for this purpose, I will show you what to do. Let me set the IP address first. I don't forget it. Then I will show you how can understand this tunnel is really connection is okay or not. So we choose the range of the IP address for the tunnel 192.168.50.1. I choose 1.255.255.255.0. Okay. Now I want to show you a useful command, keep alive. Keep alive will check the other interface of the tunnel and check it. Is it really active or not? If I make it question mark, you will see, but the default is 10 seconds. It's 10 second by 10 second. We'll go and check it. The other side, the interface is up or down. Really, it is up or down. Then never show by the fake is up. This is now it is fake. So I set it 3 second by 3 second, check it, and how many times retry you can set it also. I set it okay 3 times retry to check the keep log, and now it will start to check the interface is really active or not, and after that you will see it shows down. It means that this is the good way to understand really the interface is up or it's down. Okay, see, now it shows the tunnel one. It's not really up, and its state is down. In fact, something else that is very important here we had tunnel mode. Our tunnel mode is a GRE. You can also see we have different kind of tunnel, but now we are focused on GRE. So GRE, and now the GRE that we are setting it is point to point. So if I make a question mark, you will see the IP. I can choose IP, and this mode automatically, when we didn't configure this one, is by default it's like this. So no need in point to point you write it like this, but just I want to show you. But later for multi-point, it's something that we must set it. That later we will talk about it. So just I write it here. Now take a look. Uh, we say that encapsulation, GRE encapsulation, generic route encapsulation. You know, the packet, the data, it will go in a encapsulate in a header and go through this internet, and through this internet nothing will happen because just look at the source and the destination inside the tunnel goes, and don't care about these ranges what happening in middle of here. But this data maybe we later also capture by a Wireshark and show you. This data is clear text. Everybody can read it. If some hackers man in the middle can just monitoring the data and it is clear text, then it is necessary we use IPsec to secure this GRE. And later we will talk about the security of the how make it more secure. Okay. Uh, sorry. Uh, okay. Uh, Here there is a problem that maybe happen if we want to more secure or and add the header go bigger by encryption of IPsec also. The header may be bigger than the normal size and the fragmentation happen. How can we stop fragmentation and stop the big size data that it will stop and make a problem for us in transfer? So I will go and set maximum transfer unit. You know, in the router, if you go and check it is 1500 by default. And so I've set it 1440. Then I will explain you. And also, you need to set a layer for maximum segmentation. Also, we need it to set to be set with our MTU. So I will go and say that for maximum segmentation, I say that IPTCP adjust maximum MSS. Uh, in normally when you set the MTU it's 1440, and any number that you set here 40 make it 40 less than MTU, so I make it 1400. Okay. uh, Almost we can set almost for security you can set tunnel key. You make it the tunnel more secure to both sides check the tunnel key. For example, I set it tunnel key 10. Okay. You can, there is some other configuration, but this is the basic configuration. I show you how to create and use the tunnel. So I am going the other side and start to config now in router 3. So I am going in configuration interface tunnel 1. I choose tunnel source. Okay, yeah, because we have a key applied and key, so it shows down. So the source is from here goes that side. So the source is F00. The destination, what is our destination? The destination goes from here and come here, the destination. What is the interface of F00? It is 60001. So I put 6001. Okay. Then after that, I must set it shows up again will go down because of the tunnel key. It's not right. We must set the tunnel key, then it will always remain up and keep alive. Now I set IP address 192.168.52.255.255.255.0. Then keep live. Sorry, 3 seconds, 3 times. I set it, and just for the practice, tunnel mode GRE, and it is point-to-point IP. Uh, Tunnel key. See, it shows down because we didn't set the tunnel key. We set tunnel key 10. Okay, I add tunnel key 10. Now it will go up because the key both side now is okay. It's if we do just for verification, we do ping 192.168.51. We must ping it. You can see. So now the tunnel is up, and you can ping both sides of the tunnel. Here also, you can check it. Do ping 192.168.52. Yeah, both sides is okay. Now from this tunnel I want to transfer some route. So I will make a EIGRP routing. I add the loopback and the interface of the tunnel in that router IT. So I go in router EIGRP Cisco, then address family IPv4 autonomous system 1. Now I add the network's range. It is 192.168. The range of the tunnels 50. The wild card is 000.255. I add also the loopback in router 1 192.168.10 000.255. Okay, now I am going the other side in a router EIGRP Cisco address family IPv4 autonomous system. I choose same one. Network network. I add the 192.168, the IP of the tunnel 000.255. Then the loopback. See, I add the neighborship between the tunnels now happened. I add also here. Also, you can see, and now I add the loopback of here. It is /16, so 172.168.18.0.0.255.255. Okay, so I make a router EIGRP in the tunnel, and now you can just verify if I get the show IP route, I must in show IP route see the EIGRP. This side can detect this route by D, it means EIGRP. So I write show IP route, and you can see that in router 1 detect this range of the loopback from the side of the tunnel 1. Vice versa, here also in router 3 must learn this loopback from the side of the tunnel. Let's check. Show IP route, and you can see here learned this loopback from the side of the tunnel 1, and they can communicate together. If I ping, because now we have the route, if I write for example 1 1, and I can easily ping together. So this is the cool way you can communicate between two branches point to point by this way. I hope you enjoy this video. Please follow me on YouTube, and subscribe, and if you like it, please like it. If there is some things you think is necessary, please write it for me. Thank you so much, and have a nice day.